All right. Hello, everyone. My name is Brian Gardner. I am a Android developer, consultant, and instructor for Big Nerd Ranch. And this morning, or this afternoon for y'all, I get to kind of talk you through Jetpack Compose and present kind of a little demonstration and example that y'all can follow along with to kind of learn some of the basics of Compose so you can see how it's used and kind of get a feel for it. Um, I will preface this by saying that Jetpack Compose is still in alpha. It is currently alpha 4, I believe. So I would advise some caution about adding this to any sort of production app because the API surface is bound to change quite heavily, perhaps. But I think it's going to be a good thing to know going forward. And I'm very excited to see this kind of updates and changes being made to Android. Now, the workshop goal here, there are three of them. So the first goal is to help y'all learn how to display the views in Jetpack Compose, as well as configure these views. So specifying how large these particular views are, maybe whatever kind of padding they may need, things of that nature. The second goal of this workshop is to discuss state. Now, state is kind of the central focus of Compose. It's very different from the existing Android view style, where each view kind of has its own state, and you're very much responsible for getting the state from those views, setting the state on those views, and it's easy to kind of get out of sync sometimes. Compose seeks to simplify that inside of our applications, whereas the views now are they listen to state, but they don't have any internal state of their own. And the last goal here is to learn how to theme a Compose application. So this works a little bit differently from the existing system, but I think once you kind of see it and use it, I think you'll enjoy it. Now, if you do want to follow along for the workshop, this does require Android Studio 4.2 Canary. So if you don't yet have that installed, I would say go ahead and search on Google or your preferred internet browser, search for 4.2 Canary, go ahead and start getting that downloaded. The reason for this is that Compose, as it is still in alpha, the tool chain for it is only in the Canary versions of Studio, so it doesn't exist in 4 or 4.1 yet. Hopefully soon. I'm keeping my fingers crossed. Once you are downloading Android Studio 4.2, if you want to work along with the project that I have, you can find it at this link. It's just bit.ly/compose-koans. And you can clone this particular repo and, like I said, follow along with the implementation. Now, there's a few things that I'm going to cover. So I'll kind of give some slides presentation at first to give you all some time if you want to download Android Studio or clone the project here. The project link will stay in the bottom right corner of my slides, so don't worry about having to type it out really fast as of yet. But I'll just kind of at a high level cover some of the requirements that's good to know about for Jetpack Compose, starting with a couple Kotlin language specific features. So the first thing you're going to need is something called higher order functions. Now, this definition here on the screen is courtesy of Wikipedia, and a higher order function is effectively one that either takes another function as an argument or returns a function as its result. So you either get a function as input or return a function as output. Compose relies heavily on higher order functions. Pretty much every view that you're going to be using inside of Jetpack Compose takes in a content function as the last parameter. So this is things like if I have a button, say, that I want to display, that takes in a function as the last parameter, and whatever is returned by that function dictates the content of my button. So this is kind of where the higher order functions come into play, because we're passing functions as parameter and kind of nesting functions and things like that. And I think it creates kind of a very clean representation of your view, allowing you to specify exactly what content you want in what particular place. Now, the other Kotlin feature that Compose heavily relies on is named arguments. This particular definition is also courtesy of Wikipedia. Shout out to Wikipedia there. Named arguments effectively means that when you call or invoke a particular function, you can specify the name of the argument that you're passing. Now, this has a couple of benefits. The first is that it makes it very explicit about the data you're passing to a particular function. If you have one function that takes 4 string arguments, if you don't pass the names for any of those arguments, it can be like not very clear exactly what each of those arguments are for unless you go into the actual function declaration. If you have named arguments, you can specify the name of each of those parameters, so it's a little bit more clear what each of those is for. So Compose relies pretty heavily on this. You don't have to use the named arguments if you don't want to, but I think oftentimes it makes it a little easier to understand. The second benefit of named arguments is that you don't have to pass the arguments in the order they're declared if you provide the name for those arguments. So when I invoke a function, if you wanted to, you could reverse the order of all of the arguments and the compiler wouldn't complain as long as you provided the name for each of them. So that's kind of at a high level, the kind of specific Kotlin syntax that Compose relies on. So the next thing I'll kind of cover is the various dependencies that Jetpack Compose has, as well as how to enable it in your projects. So the Compose library is broken up into multiple sort of sub dependencies, and each of these kind of focuses on a separate area of Compose. So we have things like animations. So all of the animation stuff is inside of one specific dependency. You have the compiler that allows for the composable functions, foundation things, material design things, runtime things, UI things. So there's a lot of dependencies you can add to your specific project, and we'll kind of touch on some of those throughout this workshop. Now, to enable Compose in your projects, inside of your module, your app level build.gradle file, you can just pass in a build feature, say, hey, please enable Compose for me. That will turn on the compiler for you and kind of set everything up. And then you're going to want to set some specific Compose options. You'll typically want to pull these from the documentation for Compose, since whenever Compose kind of updates, you will typically have to update like the compiler extension version and so forth. So it's a good thing to keep an eye on those release notes if you're kind of interested in Compose. So at this point, we have kind of an understanding of the Kotlin language features that Compose is going to use, as well as some of the dependencies and how to enable Compose. So now I'm going to just kind of talk about how Compose differs from the typical view system. So with Jetpack Compose, you do not use XML to declare your views. There are some caveats for that. If you want to use an existing Android view inside of a Compose view, you can put that into your Compose view, but I'll talk about that a little bit later. So with Compose, everything is done inside of Kotlin code, so you don't have to touch XML if you don't want to. And oftentimes, there's pretty much kind of a one-to-one correlation between your platform view and the Compose view. So in this case, we have text view on the platform, and we have a text function in Compose. There's a button on the platform. There's a button in Compose. So some things are the same, like button. Other things are different. So edit text, for instance, is that on the platform, but it's called text field in Compose. And recycler view is probably the most different one. It's called recycler view on the platform, but in Compose, it's called lazy column 4. So I'll talk a little bit more about that one when we actually get to the lazy column 4 piece. So those are kind of how you declare your views. So you say, hey, I want some text. You say, hey, all right, I'm going to call the text function, pass the text parameter to it. But oftentimes you need to modify or configure those views. And there is a specific modifier class that you can use. Pretty much every Compose view that you're going to use or create yourself is going to accept a modifier object. Now, modifiers are used to do a lot of things. They are used to add padding to a view. They're used to specify the size of a particular view. In this case, we can say, hey, please fill the max width of whatever the parent view may be. So there's a ton of things you can do with modifiers. I wouldn't try to enumerate all of them here because we would be here for quite a while. And we have some more exciting things to get onto. One other thing I'll kind of mention is dimensions. So dimensions are potentially one of my favorite little pieces of Compose. They effectively have functions for the density independent pixels and scale independent pixels. And you just call these on integer values. So they're just extension functions on the int class. So in this case, if I wanted maybe a button that's 100 dips wide, I could just say call 100.dp, and that would give me that value. Same thing is true for these scale independent pixels. You call the SP function, and that will return you that associated value. So this is great for things like text size because it's going to take into consideration the user's accessibility settings. So the last thing I'll kind of cover before diving into the koans is state. Now, I mentioned before that Compose deals with state differently than the platform views. Platform views have their own internal state. So when you set text on a text view, that text view is actually going to hold on to that value, and you can query that value back out. Compose, on the other hand, is meant to be is meant to be kind of more reactive in a sense, whereas the view that Compose gets created is meant to be a representation of the current UI state. So you can kind of think of it as your Compose functions are the function wrapping the state, and they return whatever the view is that represents that particular state. This makes it so that if the state were to update, you basically just pass that value, that new state, back to your function. The function may return something different as a new view, and Compose can re-render that view on the screen. Fortunately, Compose is very smart about how it does the re-rendering. For a particular view function, if the parameters to that function do not change, Compose isn't going to re-render that particular component because your Compose views should be functional. When you pass in the same input, you should get the same output every time. So you should really try to avoid any sort of side effects or things like that, so the compiler can kind of help keep things very performant. And last but not least, so this is kind of a popular thought process behind this sort of state. You'll hear this quite often, is that state should flow down and events should flow up. So in this case, maybe I'm using a view model style architecture in my app. The view model is responsible for sort of compiling all of the model classes and data together for that particular screen, generating some sort of state, and then sending that state to the view and says, hey, here's this current UI state, render this. So state or data flows down from the view model to the view in this case, but the view should not send data back to the view model. The view should only send events back. So like, hey, this particular thing was clicked on or something like that. Since the view is a functional representation of state, the view should not have a reference to that state. So the view should not modify the state on its own. That's going to be the responsibility of something like a view model or a presenter, which is why we use the events there. The view says, hey, this particular thing was clicked on. Then it's up to the view model to say, okay, based on the current state and this particular event, generate a new state and send it back to the view model. All right. So that's kind of my little introduction there. Hopefully, those of you who want to follow along have gotten Android Studio downloaded and the project pulled over. So the project itself is broken up into kind of your typical koans style. So basically, if you're not familiar with koans, it's meant to be small little exercises that you do to sort of build up larger understanding of a particular topic. So in this case, the project is broken up into several packages. We have one on Compose views to kind of give you an understanding of some of the sort of core pieces that you'll use when building a UI. The second package is modifiers. So this covers the various modifiers you're allowed to use, how they work, how they impact the view you set them on. The third package is state. So we'll cover a little bit about what the state objects are, how your views can remember that state, as well as how Compose works with existing stream implementations to turn data from those streams into state that your composable functions can consume. The fourth one here is platform compatibility. So this talks a little bit about how to use Compose views inside of your platform views, as well as how to use a platform view inside of a Jetpack Compose view. It also talks a bit about how to access things like resources and so forth, because those things are still at the system level, they're at the platform level. So there has to be some sort of API to kind of hook into that. The fifth is the theme. So we'll talk about the different components that make up a Compose theme, things like colors, typography, and then actually setting up a theme and using it. And last but not least, just for fun, we have a create screen. So this is basically showing off the scaffold component. So this is adding maybe a app bar at the top of your screen, a bottom app bar, navigation drawer, kind of the major components that you're going to use. So for a lot of these, we're going to kind of work through them together if you've got it downloaded. So inside of each file, so here I started the text koans because this is the very first one. Each of these has several tasks for you to implement. So in this case, each task has a to-do function, which kind of gives you a description about what this particular thing should do. And then all the way down at the bottom of each file, there are preview functions. Now, preview functions allow you to preview your work. So if you click on the split button in the top right, it will show you both your code as well as the rendered preview for that particular function. So in this case, it's just calling each of the tasks here and rendering a preview. Now for these, it's not actually showing anything for any of them because the to-do functions here are returning nothing. So it doesn't actually have anything to render. But we can go ahead and get started. So first things first, text is going to be one of your major Compose components. You're always going to have to display some text inside of an application, so might as well get familiar with this one first. So the tasks here are create a text element that displays hello droidCon, and then check the preview to see how it looks. So in this case, we have a text function. There's a lot of ones that you can import. Just make sure that you're getting the composable function that takes in the string parameter. So here is where you can see the named parameter come into play. So we have some text here, and then it wants us to display this string. So I'll just throw it right in there. So now this composable function will display a piece of text that says hello droidCon. If I can refresh the preview, hopefully it will be fast enough. One of the things you can also do is if you don't want to wait on the preview, if you go down to the actual preview function, notice that there is a play icon next to a emulator. This will actually allow you to run just that preview on an emulator. So this makes it very nice for kind of testing your different composable functions kind of isolated. So if you want to run it on a device and see how it looks, you can do that. But fortunately, my preview's updated, so you can see I've got some text, says hello droidCon. So now, we'll just kind of keep going. Let me move this over. So next, it says create a text element that displays hello droidCon with a font size of 20 scale pixels. So I'm just gonna grab this one since the text is the same. And it says I need a font size. So I'm gonna look, and there is a font size property, or argument rather. So this is where that SP function comes into play. You do have to import this function. It'll work for me. The joys of Canary. Let's see here. It's there, but it's mad. So we will see, hopefully. Maybe it'll work. But this is kind of your receiver type mismatch. Oh, there we go. It's not a function call. So here, we've got some text, display some text, has a font size. So this is going to be kind of very much how Compose sort of works. You have your function call for a particular composable function. You're specifying all of the configuration options for how that particular thing is working. And then it's going to set itself up in that way. If you want to look at the text, you can see that there are quite a few parameters here. We have things like font style, font weight, text decoration, text alignment, overflow, max lines. So there's a ton of things that you can use to actually modify this particular piece of text. And the koans here kind of seek to make it easy for y'all to kind of learn a lot of these things. So we'll keep on going. So in this case, it says, hey, create a text element that displays hello droidCon, dark gray font color. So there's going to be some sort of text color or font color parameter. Oftentimes, if you're not sure what it actually is, you can just kind of start typing. Maybe it's like, oh, maybe there's the color here. So you can just kind of peek through them. It doesn't look like there's anything there, so we'll go with the color. With colors, there's a lot of them already built into Compose. There's a color object, and it just has a lot of default sort of values built in. So we can say, all right, maybe set this as dark gray. Let me refresh the preview, but we'll keep going while that refreshes. So here we have hello droidCon with a bold font weight. Oop, here we go. So the preview refreshed, you can see our original text here, task 0. Task 1, bigger text size because we specified 20 scale pixels, and task 2 has dark gray text, which unfortunately is not super visible on that background, so I apologize for that. So here we have task 3. Say, hey, we have hello droidCon, and then we want a font weight. So I start typing weight, it says font weight. And then there are font weight objects here. So you can say, hey, give me a bold font weight. This is kind of something that I really enjoy about Compose, is that kind of every property that you specify for something here has an associated object that is the particular type. It's not like they're asking you to pass in an integer for the font weight. It's actually going to be some sort of like standard or constant on a particular class. Now, this might be actually an integer in this case. Unfortunately, I don't have the sources downloaded for this. I think this is a known issue for the current either version of Studio or Compose, one of the two. So unfortunately, I can't show y'all the actual source. But either way, a lot of these things, as I can show you maybe the So color has a color object, font size has a text unit object, font style has a font style object. So you have a ton of things you can set there. Whoopsies. So we set some font weight. Go ahead and refresh the preview. All right. So here we go. So the next thing I have, if I can make this thing smaller. So I want to display some text with an end text align. And then there's a little tip in here for that. So I'm going to grab this text. I can start typing align. There's a text align. And then very similar, there's a text align object, say text align end. And then I have my text here. The issue you will run into in this particular case, and the tip may kind of give it away here, is that by default, the text here is only going to take up as much space as its content. So you can think of it kind of like wrap content. So here, you'll notice the preview here looks a little different. That's a little kind of thing I added here. So preview task 4, the preview function itself has quite a few parameters that you can add to the annotation. The width is one of those things. So I'm basically saying, hey, please preview this as if it's on a screen with 400 dips of width. You can also set things like the height that you want it to be, the API level, font scale, showing decoration or backgrounds and things. But either way, you can see if I kind of hover over this, the box here is the actual bounds of this particular text composable. So it does have the end alignment set, but it's squished, so it's not going anywhere. So we need to tell it to basically take up the full width in order for that text alignment to work. And this little code snippet here will do that for you. So you got to add your modifier. Go ahead and import that. Make sure you're choosing the Compose version, not the Reflect or the NIO. And then import the fill max width function. Redo that. So this basically modifies the text and says, hey, please take up the full parent width. And if that runs, the text should get pushed over to the end. 400 may have been a little big, but you can see the text is now end aligned there. Other things you can do are set things like max lines. So there's a max lines parameter. You can set something like 3 in this case. One thing that this will need to do is the max lines doesn't really appear if we have very short text. So I'm just going to sort of paste a whole bunch of text in here. So hopefully we see the max lines there. There we go. So as it depends how many, how wide our preview is whenever that refreshes, but we shall see. There we go. So we have all the hello droidcons there. Make that a little bigger. See, there are 3 lines, fortunately. When you have a certain number of lines like that, oftentimes you might want to ellipsize the end of it, so it's not just kind of cut off. By default, it just cuts the text off. So if you want to modify that, there's an overflow, which has a text overflow. You have clip, which is just kind of chops it off, or ellipsize. I'll swap this to maybe 1 max line to make that a little bit more easy to view. As you can see, the preview kind of like scrolls a lot as it's updating and things. It's not the fastest thing in the world, but again, it is still alpha. So there's going to be a few things here and there that aren't the best. All right. Let's see, 849. All right. If I can get this to move. So the last thing here is, if I can get that to move, there's also a text style object that you can specify on your text. This controls things like color, font size, text alignment. So you can sort of move all of those things to a specific text style if you want. If you pull out all of your text styles, you can kind of share those across different text elements. So what that looks like, maybe I'll steal this one up here because it's a little shorter. But it gets you kind of the very functional style because it's like I'm passing in different parameters here. There's a text style. Oops. And then I need to pass in the actual properties for this text style. Make sure you pull in the compose one. And then things, you have properties like color, font size, go, and alignment as well. So this allows you to kind of pull all of these parameters out to an individual object. So again, if you wanted to share this particular object, you could do so. Maybe if you wanted to pull this text style to a parameter for this particular function, you could do that and have the, like, be a little consistent with your text styles and so forth. So that's text. We'll kind of keep going. So I probably won't end up doing every koan in here. That's kind of more for y'all to do. Work through the various things because there's quite a few in here, and this should hopefully kind of give you a decent sort of starter for a lot of things. But we'll try to get through a decent number of them. So buttons, again, are going to be another very big component. Users are going to need to interact with your app. You're going to want a button for that. So there's a button object or button function you can call, and it takes two parameters. The first parameter is an on-click listener. So you have to pass in a lambda or function that responds to the click. In this case, I'll just pass in an empty one since I don't want this one to do anything yet. And then the second parameter it takes is a function that provides the content for the button. So this is kind of where you can see that higher order function stuff come into play because the button is actually taking in a function as a parameter as the last parameter, although the on-click is also taking in a function as well. So in this case, we just want it to return some text. It says, hey, please click on me. And then we can actually build that. So buttons are very extensible in Compose. They don't require you to only display text like the platform ones do. They're not built off of text view or the text. So you can really realistically have anything inside of that button you want to. Images, I would say icons, but there's actually an icon button class you can use instead. Now, if we do actually want to do something with the listener, you have to pass your listener function. In this case, we'll just log something. Say hello there. Now, unfortunately, with the click events and things, those don't really work inside the preview. So you kind of have to run these inside of an emulator or on a real device in order to see them actually work. So that gives me the chance to show off this. So this is the preview task to check out that one that I just did. So you can say, hey, please run this particular task, and it should spin it up on my emulator. You'll see that the preview is going, and that's mostly just because it's setting up. It rebuilds every time you run. See, there's our second button. Sometimes things work better than others. Let's see if this can go. There we go. So we got our little button. We can check in logcat here, and it should output when we click on it. So you see, it's got our little log message, so we can actually see that it's working. So that's a good way to test your components if you actually need to run them on a device to see something like a click function actually fire. So buttons have a lot of other parameters, just like your text does. So maybe you want to disable your button. Um, so there's a enabled parameter that you can call, and that will basically kind of tint it and make it clear that that button is disabled. You can add things like elevation to your buttons and so forth. There's really a lot that you can do. In this case, we need 8 dips. So previews refresh, so you can see kind of this button is grayed out. That is the enabled there. You can set your elevation, the dip function. I gotta make sure to import that. You can also specify content padding for buttons. So if you want to give it a little bit of extra space around whatever content you have, you can do that as well. There's a padding. Here we go. Let's see. What does this one need? A padding value. All right. Padding values. Oop, not published API. Let's see what padding values needs. So this one just needs 4 parameters: start, top, end, and bottom. So you can specify that for each of them. Oh, looks like there's another version that takes all of it. That's perfect. That's exactly what I want. So this is a good example of kind of what you find in Compose. It's like, oh, hey, I want to do something a certain way, or it's like, I just want to provide the one parameter for everything, for all of the padding, and it's there. I think the API team has done a fantastic job kind of thinking about how Compose can best serve the needs of Android developers and make things a lot easier for us. And it really kind of helps in that way. So you can see now I have some horrendously large padding on my button using that padding value. All right, so I'll start going through these a little quicker, probably not doing all of them. So y'all can kind of flex your knowledge and do a little bit of research for each of these things. So icon buttons here. So these are buttons specifically for showing icons. They get some styling for that, but this allows me to also show you the icon class. So there's a specific icon that you can provide. And there's a couple of different ways to grab an icon. And it depends on what resource type you're using. So right now we have drawable resources, which are like PNG images, but you can also use vector images, which are your XML. So in this case, we need a, there's a drawable or an image resource function. So this will actually access the image resource file. So image resource is only for your like PNG images and things. And I need to import my R here. Come on. Come on. There we go. So IC person here is just a PNG image that I generated from the kind of built-in clip art from Studio. So that will actually display that particular resource. If you do want to show a vector resource, there's a different version of the icon here. You can instead pass it a vector resource. So these are different. I'm assuming like however they load these things depends on the type that you're trying to load. But I think they're currently working on kind of unifying this API so you don't have to specify like this one's actually a drawable, this one's actually a vector, because it would be kind of painful if I say swapped IC person here to a vector version, then I would have to go in and say, all right, every time I use image resource, I now have to use vector resource. It's not ideal. So while each of these loads, I can show you the, let's see. So icons also have things like colors and tints that you can do. I'll leave that one for y'all. But when you want to show something like an icon button, this is very similar to your button. Takes an on-click function. going to leave that empty for now. And then it takes a function that returns the content. So in this case, I want to have my icon, say a vector resource, add heart. There we go. So icon button just like allows you to, it's made more for displaying icons, as the name is implied there. You can see here it's got the on-click function, takes in a modifier, which we'll talk about, has it enabled, interaction state, and the content. So here's the actual button. It's got the icon in the middle, it's got some padding around the outside, so it's actually clickable. All right. So I'll go ahead and move on to column to make sure we get through everything. You can think of column as your vertical linear layout. So it allows you to sort of declare whatever children it needs inside of the column. So there's a column that you can use. You don't necessarily have to add any parameters to it if you don't need, but there are a bunch if you want them, if they'll show up. Oh, come on. Oh well. But there's a lot. So you have like modifier. You can specify vertical arrangement. If they don't take up the full vertical space, you can kind of move them up and down if you want them anchored to the top or the bottom. There's horizontal alignment, so you can move them to the start or end and so forth. And there's some others. You got your children declaration there. So this one, I just have various text to display. So I think I can just iterate over the text here. So do something like that. Make sure I import the Compose version. Go. So we have that. Let's see the split and refresh, and we can kind of see our column here. So as you can see, this kind of makes it easier to like create all of your data. So instead of having to actually like declare text and say, all right, text to display indexed at number 0, you can just iterate through them and generate your things here. So that will actually create 3 separate text components for my preview. So there's other parameters to the column. I'll leave those for y'all. The one component I think Android developers like the most is the lazy column 4. Now, if y'all remember from before, this is the replacement for recycler view. And I think you will enjoy kind of how easy the recycler view style view is inside of Jetpack Compose. So here, maybe I have a list of items that I want to display. There is the lazy column 4. First thing is this takes the items that you actually want to display. So this can be, in this case, a list of text, or maybe like a list of your domain model objects. And then inside of the Lambda here, this is called for each item that you want to display. Whoops, go. So yeah, it passes your items here. There's also different versions like lazy column 4 indexed if you need the index in that way. Takes in modifiers, takes in the list state if you need it. Content padding. So you can see there's a lot of different items here. So in this case, I believe this can pass in the item. So the Lambda here takes in the particular item for that you want to display. In this case, it's just a string. So I can just say, hey, please display my item, my text item as a string, and I can show that inside of my preview. My preview is not there. That's fun. Let's see. I need a preview function. Okay, so we can make one of those. We just say, hey, add the preview annotation. You do have to add the composable annotation. This is what specifies something as a compose view. And then just say fun preview task 0, column 4 koans, task 0. There we go. So now my little preview pane pops up. It'll actually refresh and it should display my items. As you can see, it is quite large for the preview. And it should hopefully generate my items in here. If it doesn't, I can always just run it in the emulator. Let's go ahead and do that just in case. Oh, there we go. So it displays all the items here. It's not super exciting because it's not, you can't like drag it in this case. But it is a actual scrollable list. It has a lot of the same behavior as a recycler view. But as you can see, it is much less code than a recycler view would be. There's no adapter, there's no view holder, anything like that. So it is, it's quite a bit nicer, if I do say so. Now, row is, think of this like a horizontal linear layout. It just separates things out into rows. So just say, hey, give me a row. This is going to be pretty similar to your column implementation. You can basically just iterate over your text to display and then just create a text item. Import that. Got some text, it'll display it in a row. This one may be a little strange or strange behavior just because it's text displayed in a row. This may be better for like icons or something like that. But it's useful to have and fairly simple to set up. All right, I think the last one I'll cover real quick in the compose views, I'll leave the other for y'all to kind of go through, is box. Now, box you can kind of think of like your frame layout. It's just kind of a generic container that holds some stuff and you can kind of move them around. So you've got a box here, not koans, I just want the box. Got to import that. Make sure it's the compose version. And then you can put, again, whatever you want to inside of the box. Maybe I want an icon here. A vector resource, maybe. All right, give me a heart icon. See if I can import that. There we go. So box, again, is kind of your frame layout-esque kind of thing. There's some properties on here. Let's see, open up the box. So you've got your modifiers and things. You can set things like alignment. So you can kind of think of this similar to kind of gravity on the box. And then each of the child objects has a scope set on them. So oftentimes you can sort of arrange the child objects based on whatever scope you're currently in. This is typically related or relevant for modifiers because different things like box scope has its own modifiers declared on it. There's gravity, which seems to be deprecated. Boop. What's different? Align, it looks like. There you go. So you can like align this particular item inside of the box. In this case, again, the box is only going to shrink down to match the content. So if you want to say maybe fill the max width first, and then you could say align it. Say align to center end, why not? So you can see here, you can also chain your modifiers together. It's a little early, but it's a fun little peek. So basically, you can think of modifiers kind of like as a builder pattern. You just kind of keep chaining the things you want onto it. So say, hey, have this icon fill the max width of the box, and align it to the center end of the box. Maybe if I want to pass in, there we go. So maybe I said, hey, box, fill up max size of your parent. Then the icon will fill the max width and just align itself to the end of the box. So box is good if you kind of, again, want something like a frame layout and you're just going to align things based on kind of gravity. Box is going to be your standard choice there. I'll leave the stack for y'all, but stack basically allows you to, it's similar to frame layout, but it allows you to kind of like overlap things. So that also works by aligning the various items together. So y'all can check that out. Modifiers, we've looked at these a little bit. But there's a lot of different things that you can do with modifiers. You can do things like add padding. This is probably going to be sort of bread and butter for a lot of your modifiers. Like pretty much everything's going to need some padding. Got to import this modifier. There we go. So there's some padding that you can add. There's a padding modifier. There's a couple versions of padding here. So you can specify all of the padding. So this is just all the way around your particular view. But if you want to be a little bit more specific, you can say maybe I want 8 dips of padding on the start, 16 dips on the top. Typing is hard. There we go. And then maybe no padding on the end and bottom for some strange reason. But you can be very specific about the paddings you want for your particular view. There's also, I can swap this around. You can say, come on. You can specify a horizontal and vertical padding as well if you want those to be equal at the start and end and top and bottom. Sizing things is also done using modifiers. By default, everything is kind of set to wrap content, so it'll just kind of shrink down to however large the content of your view is. But there's a few different ways you can specify size with modifiers. So if I have an icon with my heart assets, say vector resource, I see heart. Of course, I got to import all the things. So you can do things like maybe, oh, I want my preferred height to be 24 dips, perhaps. Go. And then maybe like preferred width. There we go. Can do that as well. So you can specify maybe your height and width separately if you want to. In this case, if they're both the same, you can do preferred size instead. That will set both the width and height to that size. The reason it says preferred is because this is how large the view would like to be. But if for whatever reason there's not enough space for it, maybe if the parent isn't large enough, then there is a chance that it will change. So if I set something ridiculous like I want this icon to be 2400 dips, there's not going to be enough space for that unless you're running this on like a 100-inch TV or something. So just remember, preferred doesn't mean guaranteed. I also showed this before, but you have things like fill max width. So I can show that here. So you have fill max width here. You can also provide a fraction if you want to kind of fill a fraction of the parent. There's also fill max size if you want to fill up the entire parent. So it's like, hey, maybe my box has 300 by 300 dips. I can just say, hey, icon, please just fill up the maximum size of whatever your parent is. Now, weight is relevant to things like columns and rows and so forth. Basically, things that there may be some extra space left over. So if I have a column that it takes up the maximum size of my screen, I can specify weights for the items inside of it, and they will kind of fill to expand the size. Very similar to your linear layout weights. All right, give me a box. I want the modifier. Import that. So in this case, the column has a scope. You can see here, there's a column scope. So I can specify a modifier. Say, hey, give me a weight. Import all the things. There we go. So maybe the weight on this one is 2. Let's see what it's mad about. Maybe it's a float. Yep, it's a float. So you just have to specify these in floats. And then maybe say, all right, my other box has to be a 1, and then another 1. So now I have a column with 3 separate boxes in it. The first one will take up half because it's 2 over 4, which is the sum. This one will be a quarter, and this one will also be a quarter. So weight allows you to kind of tweak how large things are going to be whenever there is extra space in that particular class. Now, clickable is an interesting one, at least to me. So there is a clickable modifier you can add on things to make them respond to click events. So this is, I guess, similar to adding an on-click listener to any sort of view subclass. As y'all saw in the button version, button automatically takes in a click listener. So you have to specify a click listener because buttons aren't super useful if they don't do anything. But if you had some other sort of composable function and you wanted to make it clickable, you just add the clickable modifier. So maybe if I want some text here, there we go. All right. So you pass in the clickable modifier, and it works very similarly to the on-click in your button. Just takes an on-click function. You can do anything inside of here, log a message, or whatnot. So this is kind of, again, if you need anything to be clickable, then the clickable modifier is going to be the way you want to do that. Now, I mentioned before with the state, which is what we're going to be talking about next, is that your views shouldn't really be modifying the state themselves. You should try not to have any sort of side effects inside of your composable functions. So in this case, with the click event here, declaring the click event inside of the text here is probably not a good idea, because ideally the text should only know how to display some content. If it is interacted with, it needs to push that event up, further up the hierarchy to somebody else. So oftentimes what you'll see is you'll have an on-click function passed in, and then you can just provide that to the modifier here. So this kind of removes that requirement from your text and says, all right, this text can be really dumb now. All it knows how to do is display some text and notify something that it's been clicked on. So somebody further up, maybe a view model or something like that, can actually receive that event and then generate a new state for this text to display. Remove that. So compiler's happy. Let's go ahead and delete that. So speaking of state, so like I said before, your composable functions, you should try to keep them kind of as dumb as possible to the best of your ability. So text should only display some text. If it needs to be clickable, pass in the click listener so something else can implement it. Again, the view should effectively be a function of the state. Any sort of events need to notify something outside of the view so that the new state can be generated and passed back. Now, if your view does need to have some sort of state or it needs to render a particular state, there's a couple ways you can do that. So one thing you can do is there is a mutable state that you can have. So in this case, this mutable state of generates a state and a state setter. So you can see that here, I'm grabbing a state and the setter for it. And basically, whenever a composable function reads the value of a state, it automatically subscribes to updates for that state. Meaning, if it receives an update for that state, your composable function is going to recompose, meaning it's going to kind of resubmit the state value and redraw itself if it needs to. So in this particular case, this example, there is a column here. So I'm just displaying a couple things, displaying some text, whatever the current state is. And then I have a text field that displays the current state. And then anytime the text field changes, I'm calling the state setter. So what this does, if we take a look at it, is this will basically recompose my view every time I type a letter into my text box here. If it'll work, let's see. Seems to be having some issues. Stop and rerun. Well, that's fun. Well, that should work with the mutable state there. I don't know. I just spin up a new emulator this morning, so maybe it's causing some problems. So I'll get back to that in just a second. One thing I will mention here, though, is that this implementation is not ideal. The reason is this composable is creating this state and then displaying it. Now, if I was only ever displaying this composable on its own, that would be okay, because there's only ever the one state and it's kind of displaying itself. But the issue with this is every time this composable runs, it's going to be creating a brand new state object. So what we want to happen is when our composable runs, we want to create the state, but we want our composable to remember that state if it's run again. And fortunately, there is a remember function. So remember effectively gives your composable function memory. So in this case, if task one is run again, when it invokes this line, it's going to say, oh, I've already remembered before this particular state. So instead, it's going to return that existing state. Now, in this case, remember will only ever remember this thing once. But if you had some sort of param up here, some sort of state that your task wanted, and you wanted to only remember if the parameter changes, you can actually pass that to remember here. So in this particular case, if I call task one with 0 for my parameter, it'll say, okay, I haven't been called before, so I will remember this mutable state for parameter 0. If task 1 is called again with parameter 0, that gets passed to remember here, and it says, oh, I've already been called with parameter 0, so it's just going to return whatever the old state was. If task 1 is then called again with parameter of maybe 1 or 2 or something different, when we call that remember here, remember will say, oh, this is a new state for this particular thing, so it will rerun this lambda, and in this case, it would regenerate our state. So remember, mutable state allows your composables to observe the state, and then whenever that state changes, they will sort of recompose themselves. But anytime you're using kind of state or mutable state, you often are going to want to remember that state in your composable. So let me get rid of that so compiler can be happy. Now, one of my other favorite things about Compose is that they have worked very hard to get existing stream implementations ready to be used as state in your composables. So one instance is if you use something like flow to push state from your view model down to your view, you can turn a flow object into a state object, and then every time a new item gets pushed through that flow or gets emitted from the flow, your composable function will effectively get notified of it and say, oh, hey, this is a brand new state. Let me go redraw myself with this new state. So in this example, I just have kind of some delays here, just 1 second delays, and I'm emitting various items throughout the list. So what this can look like is if I want to display some text here, I first want to grab the state, which is my sample flow. And then there's a collect as state function that you can use that basically says, hey, start pulling items out of this flow, but turn them into a state object that my view can observe. You do have to pass in an initial item. So just say, hey, this is the first item. And then you can use this state inside of your composables. In this case, the state here is an actual state object, which is why I use value here to get the value out. So if I run the preview here, I'll actually run this in the emulator, so hopefully it's a little easier to see. Should see the text pop up. Oh, come back here. Let's see what happened. A lot of very angry things. Preview stream to state colons task 0 not found. Oh boy. Task 0 not implemented. Did I not comment that out? Thought I did. Weird. Let's try that again. Maybe the compiler is just a little slow. There we go. So you can see now the text is actually updating. I'm sorry, that is very small. Let me try to make that a little bigger. Say 32 dips, import that, and then rerun this. What is the matter? That's weird. Oh well, I won't bother about that. But you can see before when I ran this, excuse me, the text is actually updating. So the first value, that's my default, and then every second it's actually pushing through another value here. So this these sort of functions are going to be kind of your main way of exposing data from something like a view model. Say, hey, maybe I have a flow coming from the view model, or maybe a live data, because we can also effectively do the same thing with a live data here. Sample live data. Live data, it's not collect as state. They kind of use the terminology for the various streams. So this is actually observe as state. You pass in the initial there. So if you expose a live data from your view model, then you can basically have your view observe that as the state and then sort of pass the data around wherever it's needed. So super useful here. So this, I think, will help really separate a lot of behavior inside of applications. Your view should just be for displaying whatever the state gets passed down. Any sort of events or interactions the user has, those should effectively be called as functions on the view model. And then the view model will take that, add it to the original state, and create another state. So let's see here. So I think we're getting a little long on time, so I'll pick some stuff to work on. So ambients are one thing that you're going to want to be familiar with Compose. Ambients are ways of accessing various components or information about the system from a composable function. The biggest example of this is the context. With platform views, they have a direct context reference, but your composable views do not. They're just regular functions. They don't extend context or anything like that. So you have to use something called an ambient. So the way you do this is there are various ambients defined, context ambient being one of them. And then you can say, hey, give me the current context. So that'll just give you whatever the current context is for that particular view scope. You can also do things like getting the configuration. So there's a configuration ambient. And that'll give you the device configuration, so you can do things like check the orientation and so forth. Let's see here. View model is another big one. So there is a view model function that you can use. It will basically allow you to access the view model from the current scope. So if your composable function is running inside of an activity, it'll give you the view model scoped to that activity. If your composable function is in a fragment, it'll give you the view model scoped to that fragment. We are unfortunately running out of a little bit of time, so I won't go through these too much, but these are here with all the instructions, so if y'all want to continue working on these, you can feel free to do so. So I'll kind of make sure we get through the other stuff. When you create themes, so the theme object requires a couple things. It requires you to specify some colors, and it requires some typography. Colors, you basically specify various things like what's your primary color variant, your secondary color, and then you provide a lot of on colors. So this would be like, what color is the text that is displayed on top of your primary color? Now for each of these, there are color constructors. So light colors here. So for these, you specify things like primary variant, secondary, and so forth. You can also see there are like error colors, on error, background, on background. And this will return you a colors object, plural. So colors is basically, hey, these are all of the colors for this particular theme in my app. So you can have like light variant. You can also have dark colors. And then these values are passed the same way as well. So in this case, you can basically create these. I've given you kind of some sample colors to fill in as you work through these. Typography is interesting because you can kind of specify like what font family you want. Say, hey, I want a font family here. You have to specify some properties. Oops. There's a builder class, I think. A little low on time. So the font family, basically you pass in things like fonts. So I've actually included already some fonts in here. So I have the Open Sans TTF files. So there's regular, bold, and semi-bold. So you can say, hey, there we go, font family. And then each of these, you have to pass a font in here. Open, import the R, Open Sans, maybe the regular one here. So you say, hey, for my particular font family, just add all of your fonts. You can also add a font weight if you want. Maybe this is my normal font. But you can add the other ones. So you could add like bold in here and semi-bold. And then these are used inside of the typography object, which is actually where you set up how you want the different fonts to look in your app, or the different styles. So there are various things you can import. Make sure you get the Compose ones. Now the typography defines a lot of like various headers. So you can say, hey, maybe for all of my like very large headers, I want to use my font family. You can specify a font weight for these things. I don't know, say maybe we want all of our headers to be bold and so forth. You can also maybe specify a font size. So if you want this to be super big, actually do SPs there. So you basically say, all right, any header one inside of my view, I want to look like this. And then you can access the typography through your theme and set that data. You can set the text style on your text views or your text objects, or whatever you want. Now, the themes in this case, you've got things like you override the material theme. And in this case, this is where you have to kind of pass in your things like colors. So in this case, maybe if I grab, there's nothing in here, but it should work. So say, okay, maybe I have some light colors and fill in the colors here. Say, all right, I have some light colors, or light. Then you also need to specify things like your typography. So grab that. Typography. And then the last thing that you need here is your content. So how a theme works is it basically wraps whatever content you pass to it, so you can actually display that to your user. So this sort of applies all of the colors and styles and things to whatever content you pass to your application. So unfortunately, I think I'm about out of time. So the last thing in here, if y'all are interested, is how to create the screen. So this covers things like how to add an app bar. So you can add like a navigation icon. You can add options items to it and respond to the click events. You can add a bottom app bar to provide kind of main top level navigation. And then all of those get combined inside of a scaffold object, which allows you to sort of arrange the top and bottom bar, as well as include a navigation drawer if you're interested in. So apologies for not getting through everything there. But this project is, again, up on GitHub if y'all are interested. So let's see, let me go back here. boop. So I just wanted to say thank you everyone for watching. Appreciate y'all being here. I am a huge fan of Jetpack Compose. I am very interested to see kind of where it goes going forward. So if you want to reach out to me, if you want to work through these koan projects, feel free to reach out to me on Twitter if you have any questions. And yeah, keep an eye on the project. I am planning on continuing to work on it. So we can kind of continue to make things look good there. All right, how do I, here we go. All right, so we got some questions on Slido. I can see them. Is XML going? I assume that's, is XML going away? I think in the Compose world, that would be a yes. At least I hope so. Fingers crossed. So with Compose, all of your views are declared in Kotlin, so you don't really need any XML. There are a couple caveats to that currently. There are a few views that don't exist yet in Compose. I know the big ones are like the ad view if you use Google Ads. I don't believe the map view exists yet. So there are still a couple cases where you have to use like regular platform views with your Compose. Uh-oh, signed out. Oh well. How is it possible to make parts of text bold? So yes, there are ways of making the text bold. As far as I know, I don't believe it supports spans as of right now, but I do believe that there is some content on things like text style, where you can actually add the font weight you can specify. So you can actually say, hey, this is a font weight of bold, and it will actually bold that particular text for you. Does Lazy Column 4 support grid layouts? Not that I know of at the moment. I think that would be something that you kind of have to implement yourself. So I know there's Lazy Column 4 and there's Lazy Row 4 if you want a horizontally swipeable layout. But from what I've seen, there's not a grid version yet. But I imagine that would be something that's coming out very soon. Where can we download the sample project? Yes. So let's see. So there's a bit.ly link that you can use. It's bit.ly/compose-koans, KOANS. This bit.ly link will actually take you to the GitHub page for the project, and you can download it there. I'll also post the link to the project up on GitHub, or not on GitHub, on Twitter, so you can grab it from there as well. Will we still use fragments when using Compose? So currently, yes. At the moment, Compose doesn't yet work with the navigation component for navigation. So there's a couple of different ways of doing navigation. The simplest is to use fragment navigation like a current Android app, and then in each fragment, just set the view to your composable view for your screen. That way you can use the navigation component to do all the navigation and just kind of swap fragments out. The other way you can do it is you can maybe have a single activity and then you use kind of a state-based navigation. So that mutable state of that I mentioned before, you have a state that represents a particular screen, and you change what you want to render based on that state. So when that state changes, say, all right, maybe I'm on a detail or a list screen and I'm going to a detail screen, I would update that state and say, hey, I'm now on a detail screen, and then I would just have to re-render what's on the screen based on that particular state. Is Compose compatible with Java? Not that I know of. I don't want to say no. because I haven't actually seen it done before. I doubt it though. There's a lot of stuff it relies on in Kotlin, like the named arguments and the function passing. While it might work with Java, it would be, I feel, extremely verbose to get it working, and it wouldn't be very pleasant to use. How manage navigation. So I kind of talked about that. You can use either the fragments or the state-based navigation. There's some new sections I'm going to add to the koans shortly in the future that cover navigation specifically. But they are working on getting Jetpack Compose to work with the navigation component. And once that comes out, that is going to be kind of the recommended way of performing navigation. Why should I switch to Compose instead of continuing with XML and data binding? So I think it's just kind of a difference in how the view system is working. With XML and data binding, you are getting kind of close to how Compose is working. You're kind of generating a state with some sort of maybe view or like view model object, and then setting that object into your XML. And your XML is rendering based on that data. So it is somewhat similar there. So if it's working for you, honestly, there's probably not a reason to switch to Compose. I don't see their support for XML going away anytime soon. Plus, as Compose is only Alpha 4, I wouldn't recommend moving a production project to it anytime soon anyways. So I think it'll be quite a while before the recommended practice is to use Compose. Somebody posted the GitHub link. Thank you very much for that. Embedding fragments is a common practice. Is this possible in Compose? Not that I know of. If I understand, you mean like embedding a fragment into a Compose view. As far as I've seen, I haven't seen any way of doing that. You can create an Android platform view and embed that into a Compose view, but I don't think there's a way of embedding a fragment object specifically into a Compose view. Should you start using Compose in a production app today or soon? I would say no, not in a production app at least. Compose, as it currently stands, is a fun thing to play around with. It's an interesting way of kind of seeing how architecture styles are going to change going forward for Android. I think we'll move towards kind of a model view intent style of architecture where we're like generating states and pushing it down and the view will render it. But as it's still so early on in alpha, things are still changing very heavily. A lot of things are a little slow. They're not really focusing on performance as of yet. So I would definitely hold off on actually adding it to a production project. Would you recommend using Jetpack navigation with Jetpack Compose? Whenever that support comes out, yes, I would definitely recommend doing it that way. Because I think the APIs for it will be very good and the support should be fairly seamless for that kind of navigation. But it's not there yet. So we're still kind of waiting for that to come out. All right. Well, I don't think there are any more questions. So again, thank you all for being here. I really had a lot of fun kind of putting this project together for y'all. I hope you get some good learning out of it. Again, if you have any questions or if you're working through the project, feel free to maybe ask them on GitHub or ask me through Twitter. And I'm also looking to kind of update this koans project as well as new things come out in Compose. So keep an eye on that as well. But thanks again, and I hope you have a good rest of your droidCon.